Hello everyone, welcome again in Eng-Man YouTube channel. So in this video, we will continue our series on drilling a new well using tNavigator. Okay, we do reservoir simulation and this case is about drilling a new well and we will do this in tNavigator. So it's very useful, interesting and quite innovative reservoir simulation software. Previous video, we already exercised about adding a new production well, and the name of the well is P-P_1. And in this video, we will try to add a new injector. Okay, so currently we are looking at the saturation of oil map from 3D, three-dimensional perspective. So I will go back to 2D. All right, and then we can move the time slider to the left to the original time. And again, we will use mobile in place. Okay, so this is the location of our production well, and we can look back to see the production rate, oil production rate. So this is the flow rate. All right. And we can also check the pressure. So the bottom hole pressure keeps decreasing. Okay, until it reaches quite almost like pseudo steady state flow regime, I mean. So let's add a new injector. And let's say I want to put the new injector. We can look at this size. So 320 meters will be this long. So let's say I want to put my new injector here, maybe. So what will happen? And I will add the injector maybe here, November 2009. Let's say if I put my new injector here, right click and add well. Okay, but you can also do well addition by using this one, well actions, well creation settings. Okay, single injector, common settings. So look at this one, common settings. So I can add more than one injector and the setting will be common. The setting will be the same with the setting that I will set up here. Okay, so select this one, single injector, and setup. Okay, so this is the setup. Okay, by default, all the Z layers, vertical layers will be, will be perforated, will be opened. And go to the control. Again, the control will be based on the bottom hole pressure, and it is 450 bars. And the injection rate, I want to cap at 500 standard meter cube per day. No need for economic limits. Well, efficiency, I want to make it just one. All right, so it's quite easy. Click OK. And I want to add my well, my new injector. Okay, maybe in, now I will use Alt left key. Okay, sorry. Yeah, let's make it this one. Okay. Yeah, I've done that actually. So to see the well, just move the time slider and here. So this is our well. This is my new injector. Okay, show all wells. and well names. So you can look at my new injector in 3D view. You see the location of my injector. So it's located down deep, okay, lower than this production well, okay. By the way, at this point of time, okay, before any calculation, you can still delete the well. You can also edit the well, okay. Now you see the setting. Yeah, currently it's still shut, but later on, if we run the model, the injector will inject the water, okay. So it's the location X, Y, and Z, and the injectivity index, the PI1, diameter 0.16 meters, and skin 0. All right. I think it's so far so good. It's quite easy. Again, 3D view, mobile oil in place, and let's move to the original time. There is no injector. Again, if we move to time step 12, there will be new injector. Okay, go back to time slider 0 and run the model. Okay, so there will be change in mobile in place. You see based on the palette will be changing. And later in time step 12, there will be new injector. And there will be also, of course, change in water saturation. Mobile in place will be changed significantly after new injector. So there you can see green color. As we continue injecting the well, the water will sweep, the water will push the oil. So you can see this green color showing that the mobile in place at this flooded zone now is really small because the oil has been swept by the water until the water breaks through the well, the production well. Okay, and later on we we will check the water cut at the production well. All right, so this is the condition. You see, the mobile in place significantly changed because of the water injection. Okay, and we can check the 2D map, go back to the original time, and then let's run it again. All right, still production, still producing the oil, only one injector, I mean only one producer. Later in time step 12, there will be new injector, injecting water, flood the zone, sweep the oil. We will check the impact to the pressure and then the oil production at production well 1. Okay, so now water injection continue. You see, until later the water will break through the production well. You see, all right, it's amazing, it's beautiful. Again, you can also check the saturation of oil now. All right, at 3D view as well until the last time step. Okay, the simulation has been finished. Now we go to graphs, rates. All right. Now we can check the injector first. There is no oil rate, there is no water production rate. We only have water injection rate. Open this drop-down menu and select water injection rate. So we inject at this injection rate. So starting from 287 standard meter cube per day. All right. We set the maximum injection rate to be 500. And later we can check also the pressure here. So the bottom hole injection pressure, first the limit 450, and the simulator gives me 450 because it can provide injection pressure of 450. Okay, and it will increase the pressure on equivalent radius. It will increase the pressure, the average reservoir pressure surrounding the injector, and you can check the pressure profile by looking at this orange curve. So you see the pressure on equivalent radius increases as well as we continuously injecting water. Bottom hole pressure still continue at 450. And if you go back to the rate, you can see that the flow rate decreases. Why? Because now if we go back to pressure, now the difference between the bottom hole injection pressure and the pressure on equivalent radius keeps decreasing. So it's like the reverse of drawdown. So it's injection driving force. The difference between bottom hole injection pressure and pressure on equivalent radius. The difference between bottom hole injection pressure and average reservoir pressure. The difference becomes smaller and smaller, and that will result in the decrease in production rate. You can also check the pressure at field. You see the field reservoir pressure. Okay, the field average pressure now first decreases because of production only, and after that the average pressure increases because of the pressure maintenance, because of the water injection. Okay, so that's pressure for the injector. And what about the producer? Now it's quite interesting as well. First, the bottom hole production pressure decreases, this purple color, and after that it increases, right? It increases because of the existence of water injection. So the water injection well provide water, and it will increase the bottom hole production pressure until it reaches to a certain point, and after that it declines and it stabilizes. And that's also the case for pressure on equivalent radius surrounding the production well. First, it decreases because of only production. After injection, it increases until it is sort of stabilized. Now let's check the production rate at producer. First, we maintain at 100. You see 100 standard meter cube per day, and then it declines. And now we have water production. Previously, there is no water production yet, but now because of water injection, now we have water production. You see, water production. And we can also check the analytics, and I will untick everything. Now let's check the water cut. Go to ratios, water cut at production well. So now you can also check the water cut limit. my water cut limit is 40%, and the current water cut is still lower than the water cut limit. See, if you go down, the last water cut is 32% or 0.32. If my water cut limit is 30%, then as I said before, the workover activity will be shutting in the well. Okay. But because my water cut limit is 40 and this limit hasn't been reached, so the well continuously producing. I can change the water cut limit, let's say to be 0.3, or I can also add more injection well, or I can increase the injection rate such that the water cut limit will be exceeded, and you will see that the simulator will shut in the well. Okay. All right. By the way, let's see if we, yeah. So you can also activate the streamlines. So you see the streamlines connecting the flow between injection well and the production well. And in 3D view, streamlines, you see show grid, no? You can show the streamlines, okay, connecting the injection well, the water. Yeah, it shows the connectivity between injection well and production well. So you see, okay, it's beautiful. You can adjust the setting of the streamlines by clicking on this button. Okay. General, well, options, streamlines here. All right. Line width, let's say I increase the line width to 3. Okay, and apply, and you see the line width of the streamlines will be thicker. Okay, you can also change the color, main color, undercurrent layer, blue overcurrent layer, red. You can also apply cut to streamlines or use unique colors. If you have more than one well, you can make use of this feature, use unique color. But right now we only have one injector, so go back. I think it's more beautiful. You can also change the density of the streamline. In this case, 5 meter cube per day per streamline. Okay. All right. Let's see the progress of the streamline. So I move the time slider. So it's still on a production well. So the streamline, you see the well tries to drain the fluid from all directions. Go to mobile in place instead. So yeah, still production well. So the streamline only coming from production well. I will go back to saturation map and then injection well. Now the streamline from the injection well. It connects to the production well from several direction. First this one, the shortest distance, and then the water moves to that direction, but it flows across this Yeah, area and then go back to the production well. Beautiful, right? But the most important thing is the water has been broken through the production well. But still, the water cut only 32% at the end of the simulation. So the well hasn't been shut in. So I will deactivate the streamline, go back to the original time. So I will stop here. And in the next video, I will put a new injector even closer to this production well, okay, in such a way that the water from the new injector will increase the water cut at this production well such that the water cut limit will be reached and the production well will be shut in by the simulator. Okay, and we will do that in the next video. So thank you so much for watching and see you again in the next tNavigator videos. Thank you.